Everyone. We today are going to be continuing our trinomials review notes. And if you guys could please turn to the next page and go down to example E here. This is where we left off with in our last video. And the nice thing is that we're still kind of tackling the idea of factoring, but we're going to add in kind of one simple step here. And that is that you're going to notice here that whenever we check for our GCF, that is always the first thing that we start by doing. And the main thing that you're going to see that's different is that my GCF on this one is not 1. If I look to see the largest number that goes into both 5, -25, and 30, there is a larger number larger than 1 that goes into all 3 of those, and that number is 5. So if we have something that's a GCF that's really other than 1, then our first step just has to be to go in and divide it out. The GCF always goes on the outside. And my leftovers are going to go back on the inside after we divide. -5 divided by 5 is 1, which you don't have to write if you don't want to. -25 divided by 5 is going to end up being a -5 here. And 30 divided by 5 is going to give me 6. Now, this is where you're going to, again, notice that we're not done factoring. When we say fully factored, GCF isn't the only way that we can find factors of this. Because this polynomial here that's left can be broken down into 2 smaller polynomials. There are 2 smaller things that multiply to give us this piece here. Now remember, what's going to go in each of these spots? Whatever I'm going to put in this spot and this spot have to multiply together to give me the number that comes first. And the nice thing is there's only one way to get x squared, and that's to take x times x. Now, the numbers that are going to go in the second spot here, whatever numbers I'm going to put here and here have to accomplish 2 goals. They have to not only multiply to be the number that's on the end, but they also have to add to be the number that's in the middle. So let's start by finding some factors of 6. I can do 1 and 6, or we could do 2 and 3. Those are really my only 2 options here. Now, if we're going to look for numbers here, we want to find 2 of those pairs, 2 of those combos where, or one of those combos, excuse me, where they multiply to give me +6, but they add to give me a -5. Now, signs-wise, I'm looking at this and I'm saying, well, if I keep them all positive, I'm not going to be in a great place. 1 times 6 is 6, but 1 plus 6 is 7, not -5. 2 times 3 is 6. 2 times 3 is a +5. I'm thinking that 2 and 3 somehow are going to be my numbers. Now, if we keep them positive, you can see that that gets us a +5x, and that doesn't work. So that means let's try making those guys negative. If I do -2 plus -3, that gets me to -5. And -2 times -3 adds to give me 6. So far, I really like that combination. Now, if we think this is my final answer, that's great, but we got to hold off for a second. We want to check to see if these work. If I take x times x, that gets me x squared. We already know that that works. -2 times -3, that gives me a +6. We definitely can see that that works. Now let's check my middle terms. If I'm going to get, I just erased them all. -2 times x gets me a -2x. And let's see, x times -3 gets me a -3x. And if I add those together, we get a -5x, which is exactly what we're supposed to get. That means this is my final factored form. So what I want you guys to do right now is I want you guys to pause your video, and I want you guys to try the next example on your own. Pause your video now and give it a shot. All right, answer is up. You should have got 3 as your GCF, which you then factored out. And then your final polynomial, v squared plus 14v plus 40, that factors into v plus 10 times v plus 4. The only way for your numbers to multiply to get a +40, but also add to be 14, the only numbers that work end up being 4 and 10. Now, the last example that I got today are the ones that look a little bit odd. Now, I want you guys to kind of think back for a moment. I'm going to go off to the side here. And I want you to think about what happens when we multiply polynomials that look like this. If I were to do like m minus 4 times m plus 4, If we multiply these together, think about what this would be. We would multiply m times m first. That would give me m squared. M times 4, that's going to give me a 4m. Negative 4 times m gets me a negative 4m. And negative 4 times positive 4 gets me a negative 16. Now, if we look at what happens here, though, with my middle terms, we always combine like terms next. My m squared is going to stay. But my middle terms here, if I do positive 4 minus 4, these guys cancel out. And you're just left with the number that's on the end. When we're missing those middle terms here, it's because of the fact that they canceled. So what essentially I'm looking for here is, now it doesn't change the fact, that we start with finding our GCF. The reason I kind of skipped over it is that my GCF on this one just ends up being 1, and it doesn't change what my final polynomial was. But this polynomial here, what essentially this is telling me is that we have a middle term. It's just that they canceled out. We're still answering that same question. GCF is going to go on the outside. Because we have a squared term here, this can break down into 2 smaller polynomials. It just is asking a question for a middle term that doesn't appear to be there. We're still saying what's going to multiply to give me m squared. That's going to go in the first blank, which has to be m times m. If I look at the second blank, though, here, we're saying what's going to multiply essentially to give me a negative 64 that's going to add to give me 0. Well, if we start thinking of factors of 64, we could list a whole lot of them out. We could do 1, oops, sorry, guys. We could do 1 and 64. We could do 2 and 32, and we could keep going. But essentially, if I'm looking for numbers that are going to cancel, I'm looking for numbers like over here, where they had to be the same number, but opposite signs, a positive 4 and a negative 4. Is there something like that for a negative 64? Well, indeed there is. If I look at the last set of factors here, we get 8 and 8. That means one of them had to be positive and one of them had to be negative. Now, before I circle my final answer, we do want to check. If I do my first term here, let's see, m times m, that gets me m squared, m squared, that works. 8 times negative 8, that gets me a negative 64. And if I check my middle terms, 8 times m is a positive 8m. M times 8 is a negative 8m. And those at the end of the day add together to be 0m, which means this guy is my final answer. So I want you guys to pause your video on part H. Now on this one, I'm going to leave you a hint. The GCF on this one is not 1. So make sure you take your GCF out first and then factor. But I want you guys to tell me what my final answer on this one's going to be. Pause your video and give it a shot. All right, final answer is up. Your GCF on this one, you should have taken out both a negative and a 6. Remember, leading negatives, we always take out in our GCF. And the largest number that goes into both 6 and 24 is 6. So if we divide out our GCF, GCF goes out on the outside, leftovers go back on the inside. And this is our classic case. I have an n squared minus 4, which means my middle terms had to have canceled out. So we were looking for numbers that are going to that multiply to give me negative 4, that add to give me 0. And the only numbers that do that are negative, positive 2, and negative 2. So your job today is to turn to the homework, and you guys can now work on the homework for the day, 7C day 2.